Hi, I'm Bruce Kyle. I'm an architect evangelist at Microsoft. I work with software companies in the Pacific Northwest. I'd like to introduce Stuart Solarier. Stuart is a software architect with CheckFree and a Microsoft Most Valuable Professional.
Hello, I'm Stuart Solarier, and I blog at visualstuart.net. I'm a Microsoft MVP on connected systems, and until now, most of us have been programming in C# 1.0. From that .NET 1.1 era, and even if we've got a newer version of the language, we're still using it as if it were C# 1.0. We're going to take a look at what's new since 2003. What changes the way we program? We're going to focus on the language, not practices, not applicability, not even usefulness. So opportunity for abuse abounds. We're going to do just enough to be dangerous.
Hey, Stuart. What's today's Whirlwind?
Today we're going to go back to C# 2.0 one more time and take a look at accessor visibility, static classes, and nullable types. So let's start with accessor visibility. We're talking about the property accessors. So get and set are accessors, and we want to be able to change their visibility. So it used to be the case that when you had a property, whatever the visibility of that property was, that was the same visibility for both the getter and the setter. Now we can change one or the other or both of those and lower the visibility of them. So I can only decrease visibility. I cannot make it more visible. So in this case, I'm saying that the name property can be set only by the something class or a class that derives from something. This also works with indexers because they behave like properties too. So here's an indexer. The keyword this tips that off. The keyword this is the property name, and we're able to index into an instance of a something. And I can change the accessor visibility on the indexer as well. Now you may be wondering, why would I want to do that? It is a nice thing in and of itself, but in a later session we're going to be seeing this get used in a new and novel way, so hang on. Our second topic today, static classes. What about those classes that have only static members? For example, a class factory. I don't need to instantiate a class factory. The class factory is a utility that exists to instantiate other things. Or maybe I've got utility classes. There's just some mathematical functions. We don't need to instantiate an instance of that class. Up at the top, the old way I'd achieve something like this is I might have a class called something, and I can mark it as sealed. Now that means that nobody can derive from it because there's no point in deriving from a static only class. And I might go so far as to hide the default constructor so that nobody can instantiate one of these either. If I only have static methods, having an instance of it doesn't buy me anything, and I'm just trying to indicate to the user something about how my class gets used, what the intention of this class is. In the bottom half of the screen, we have the static class that's introduced with C# 2.0. So we use the static keyword on class, and this, if you take a look at the IL that gets generated, this marks that class as both abstract and sealed. So no one can derive from it, and you cannot add a non-static member. So if you try to, you're going to get a compile time error, one of my favorite kind of errors of all times. So we make our intention perfectly obvious to the compiler as well as to the consumers of our class, that in this case something is not a thing to be instantiated. It exists only because it has private members. Our third topic today is nullable types. We want to match the semantics that we find in databases. So there's a generic nullable of T, and it's saying where T, our metastatic type, where T is a struct, so this only applies to value types, not reference types, and there's got to be a constructor for it. So the syntax new at the end of the where clause. Nullable of T has four members that we're interested in: has value, value, and two methods overloaded for getting a value or some default value. So has value is obviously asking, is this thing null or not? So if it's not null, it has a value, the result is true. Value, go and retrieve that value. If I try and retrieve that value and it is null, this will throw an exception. So if you're calling value and you don't know yet whether that value is null or not, you may be needing to prepare to catch an exception. The two overloads of get value or default, the first one doesn't take a parameter, and that means it's going to return whatever the default value is for that object type, which generally refers to what happens if I zero out the memory in the instance. So a default value for int is 0. And so the second get value or default overload takes something of type T, and we'll use that as the default value in case this is actually null. So C# gives us some nice syntax around nullable of T. We have this query, this question mark notation. I vote that this gets pronounced int. So int x is in this case set to null, and that means if I take a look at this debug assertion that x has a value, I'm expecting that that would be false given the previous statement. If I try to get the value of x, I'm expecting that that's going to throw the invalid operation exception, and so the debug assert false in that line doesn't get executed because in fact the exception got thrown. So this illustrates the syntax for a nullable int, or as I prefer to pronounce it, int. We also have a double query operator, and I'm not really sure how to pronounce that. Here I've got an int called x, and let's set it to null. Now I can assign y the value of x unless x is null, in which case assign it the value of y. So I use the double query operator, the double question mark operator. And conceptually, that's a shorthand for the stylized use of our favorite trinary operator. So we're just saying if x is not null, then use x, otherwise use the value 5. And if we think about what's going on with double question mark, it's really syntactic sugar on top of a call to get value or default. Might want to think a little bit carefully here about what it means to cast away nullability. So let's say I've got a bool called b, and I know that it could take on values true, false, or null. If I try and write if b, because b is not a bool but a bool, then I get a compiler error because if needs a bool, not a nullable bool. So I could try just casting away the nullability of bool with a cast, and if b happens to be set to null, that'll throw an exception. Might be some difficult code ahead to write if I do it that way. My first option is I could invoke the get value or default and provide a default value to it, option 1, and option 1a is a nicer syntactic way of writing that. And another thing that we might see out there in the field is we'll ask two queries. We'll first ask if b doesn't have a value, let's go give it a specific value because I'm trying to make some complex method call perhaps. And then I can go ahead and use it with all certainty that b in fact is not null. So I'm assuming that is initialized here can only return a bool.
Hey, thanks, Stuart. For more information for software developers, see the US ISV Developer Evangelist blog on MSDN.
Hey, it's been fun. Again, I'm Stuart Solarier, and I blog at visualstuart.net. See you next time.